welcome to the third video of the series. We want to see the Arduino programming scope and also how to write up on Arduino codes for a Hello World program. So in Arduino, two main functions. You've got a main and then you setup. So upon reset, upon powering on, when the Arduino wakes up, looks into, so let's say start, looks into the setup to configure itself. So upon start, it goes straight down into the setup. So it goes into the setup function. And in the setup function, you will find that's where you declare your pin configurations. So because most of the Arduino pins are multi-purpose, so can be used as an input, output, and some of them have other functions as well. So in the setup, you know how you are using the IO pins. And after the setup where you have your variable declarations and everything, it goes next into an infinite loop. Most other applications are designed to run forever anyway. So this infinite loop where you keep executing your main program for you. So the loop will run continuously until you reset or you switch off your Arduino. So outside the setup, you can have your global variables. The setup runs only once, so it runs one time, whilst your loop runs forever, so the loop will keep running as many times as possible. So just bear that in mind when you run your code. Welcome back to the main screen. I'm on Tinkercad. So we're back on Tinkercad. Just want to clean the interface a little bit. We can write our own code. So from previous application, you press the resistor, it's R to rotate across. You can drag and drop. Save space. To create another LED, just do Control-C, Control-V, highlighting. I want to change the color of the LED by pulling the drag down, change it to yellow, copy the resistor, and then press the resistor value there. And you want to connect your resistor pin to pin 12. So let's change it to a color that reflects it yellow as well. And remember to provide the ground connections. Ground pin, let's name it black. So what to start? And first we need to configure the pin. So basically let's set pin 13 as an output. So basically they set pin 13 as output. Then after we set pin 13 as an output, this will go into our setup function. So after setting 13 as an output, we want to blink the LED. So how do we blink the LED? To blink the LED, we turn the LED on by turning pin 13 on. So basically, once we turn on 13, we want to wait for 1 second. Half a second is enough. So wait for half a second. We wait for 0.5 milliseconds. 5 seconds, which is 0.5 seconds. That's enough. And we would move to the next step and turn off the LED. We turn off pin 13. And we will wait for another half a second. And then we go all the way back to repeating the process. So this part will run in the loop function because we want the LED to run continuously. So back to our programming interface. So I think I've had. Going to the code. We follow the process. First, let's get rid of this. Pretty much the same thing. So we are aware that we need two functions for it to run. So we deployed and it's void because the setup function returns no data type for a setup, and then we need a loop as well, which returns nothing as well. So in the loop, we have the void. Loop also returns no data. We need these two functions to work. We simulate, we notice there are no errors, meaning we've got the scope right this time. And in here, we want to set the LED and on set the output pin. So we need a PinMode function. And the PinMode function with a semicolon at the end to show is the end of the line. PinMode takes the particular pin and then the mode that we are setting it to. So in this case, in 13, the mode we are setting it to is output. And what we want to do, as the algorithm said, basically turn on pin 13. So to turn pin 13 on, we do a digital write. Pin 13. And what do we want to run to set it to a high? So high is the same as a 1. I'll send in a high voltage to it, or voltage source in this particular case, sending a 5 volts to it. Then we use the delay function to delay 500. Then again, we want to turn it off. So to turn it off, we do a digital write. And then set it to delay for another 500 milliseconds. Start your simulation. You notice the LED blinking, same as the onboard LED as well. So in this particular program, we've used the PinMode, we've used the digital write function, and then we have used the delay function as well. If you want to see quick reference to how the on there, you notice the digital I/O. For digital I/O, we have used the digital write to get the digital I/O there. You've got functions for analog I/O, you've got the mathematical functions, you've got the random functions, trig. And if you come to set in terms of time, dealing with time, we've got the delay function as well. And then you can search for PinMode. And the PinMode is also part of the digital I/O. So you've got digital read to read from a digital signal, digital write, and then the PinMode function that we can. So if you click PinMode, it gives you in and PinMode function taking arguments of the pin and the mode that we are using. So these are the functions that we've used for this particular code to make the LED. If you want to stay tuned for more videos to see how we can simplify this code in case we want to make changes, tune in for the next video.